Problem 55 states, you're driving along at 25 meters per second with your aunt's valuable antiques in the back of your pickup truck, when suddenly you see a giant hole in the road 55 meters ahead of you. Fortunately, your foot is right beside the brake and your reaction time is 0. So for A, they want to know, can we stop the truck before it falls into the hole? And for B, they want to know if the answer to part A is yes, can we stop without the antique sliding and being damaged? They have given us the coefficients of friction for static friction, and that's 0.6, and for kinetic friction, it's 0.3. So, to start off, I drew the pickup truck here, and its velocity is going towards the hole at 25 meters per second. We know it's decelerating to avoid the hole, so the acceleration is going to go in the opposite direction. We know our starting position is 0 meters and the hole is over here at 55 meters. So first I want to identify all the forces acting on the pickup truck, which is the force of gravity, normal force, and kinetic friction since it's in motion. And then for the antique box, it's got the force of gravity as well, normal force, and static friction because it's not moving. Shown again that the acceleration is going backwards. So to draw this out on a free body diagram, for our truck, we have normal force going up, gravitational force going down, and the kinetic friction going parallel to the ground in left direction. And it's going to be the same for the antiques. The static friction is going left because the acceleration is going that way. So for part A, we want to start off by breaking down our net forces. So for the x component, we know it's just negative force of friction because that's our only one on our x coordinate. For y, we know it's 0 because there's no net force, or the net force is equal in the y direction. So positive n minus gravitational force. And we know our equation for our kinetic friction is mu kinetic times n. And we know our force is equal to the mass times acceleration. So we know our n is going to be equal to mg because gravity is mg, so mg minus mg, we get 0. So coming back over here, we can do some algebra, get rid of that mass, and end up with our equation for acceleration being mu kinetic times gravity. So plug in our numbers, and here we can show that negative 2.94 meters per second squared is how fast we would have to decelerate in order to miss that hole. So using our equation to find the acceleration of the truck, we use this equation here, plug in some math. So the truck would decelerate at 20.545 meters per second squared. So obviously negative 20.45 meters per second squared is a much greater deceleration rate than the negative 2.94 meters per second squared that we need. So yes, the truck can stop. So for part B, same strategy. We know the max friction is mu static times n, and we know that the slipping is going to start when the static friction is at its max. So Fs max is mu static and static friction is ma. So like I said, same strategy. So the deceleration that that would cause the slipping would be negative 5.886. And from part A, we know that we can stop before the hole if we're decelerating at negative 2.94 meters per second squared. So yes, we can indeed stop without damaging those antiques. As far as what this problem relates to in class, it goes along with what we're learning in chapter 6 about friction, force, gravity. And for our learning goals this week, this helps us to draw and effectively use free body diagrams, use models for friction, and solve strategies of force.